Hi there. We're going to show you how to create a orbiting camera. Actually, we're going to show you how to create an orbiting camera that we can control using buttons on our keyboard. But we also show you how orbiting works in the editor. So first off, let's take a look at how orbiting works in the editor. So I'm going to create an object here. In this case, just a simple cube. And let's say I want to orbit around this thing right now to get a different view of it. Normally when you move the camera, you hold down the right mouse button, and when you do, you get a little target in the center, and then we can kind of look around. You can use the WASD keys to kind of move the camera around. But if we instead, as we're holding down the right mouse button, press Control, then as we rotate the mouse, wherever that target is intersecting, we orbit around that. So that's super useful in the editor, because if you imagine if we're in a space here, just create some terrain here, we can kind of very quickly kind of get a different perspective and rotate around an object just by using that trick. So basically here it is, and then I'm going to use that, hold down the right mouse button on Control here, and I can kind of spin around this object really easily. So that's one way to think of orbiting. And now what I'm going to show you how to do is to create a orbiting camera that we can kind of control the direction at playtime. So the idea is you're in a live show or something, you want to have it spin around something interesting. You can kind of do that by setting it up this way. It's going to involve a little bit of script, but it's not too bad. I'll go over every step carefully. So the trick here to make this happen is we are going to create basically a camera. So start by creating a camera. So we go to on the toolbox under cameras, and then on the bottom hit camera. I'm just going to create an additional camera in this scene. Right click to exit draw mode. So when you create a camera, it also creates a viewport for it, so we can kind of switch to that viewpoint. But we're going to do this all from the default terrain space viewport for now. So after we created this camera, we're going to create a parent node for this camera. And I'll explain to you why in a second. So to do this, we're going to go to Entities, and then we're going to find Node on the bottom list here. And then I'm just going to create a node here, wherever we want. And what this node is going to represent is the fulcrum of our spinning camera. It's going to basically spin to kind of watch this node point. And in order to set up this situation correctly, we're going to, on the hierarchy view, we're going to drag and drop the camera onto that node. So now that node is the parent of the camera, and when I spin that node, the camera will spin around that node, which is what we want for orbiting. So now what I'm going to do is we basically now want to set it up so that, well, I'll show you a couple different things we could do here. Let's say we just want to have an animation where it's constantly orbiting around that node. To do that, what we can do is on the parent node, we go to Transform, and on the rotation, basically what we want to do is control this value here, this Y value. We can just create a signal on here. I'm going to create this, hit the little button up here, hit New Number Signal Controller. Then I'm going to create a new signal for that signal. And I'm going to create a new waveform signal. And so when you hit play, you'll see that the camera kind of does this, but we want it to spin around kind of infinitely. And so to achieve that effect, you have to set the amplitude to 360, because we want it to spin around one complete circle. And lastly, we got to click on the actual waveform signal here, and we got to set the wave type to sawtooth. And now you can see that the camera will always orbit around this point. And I'm going to adjust the wavelength, slow it down a little bit. Now we have a camera that never stops orbiting around it. So if I switch back to the camera viewport, we can kind of see that we're orbiting around this node. So this is if you just want it forever spinning while you're doing other stuff. But what if we want to be able to control the spinning, maybe using the arrow keys on the keyboard, and we hit left, it kind of goes, it spins in one direction. Hit it again, it speeds up in that direction. Hit right, it slows down until it then inverts the direction. So to do this, I'm going to actually take this node, I'm going to remove this signal situation that I've just created here, just so that we can kind of manually set this up. I'm going to actually reset this to 0, its rotation. So to do this, we're going to, on this node, we're going to hit this little button here, and we're going to hit a new player controller. So this is basically now connecting this node to user inputs, like keyboard inputs. And then we're going to write a little bit of script, or MIDI inputs, yeah. Anything that can come in as an input. So VR controllers are inputs, MIDI inputs, keyboard and mouse are also inputs, and also gamepads are inputs as well. Then I'm going to click on that player controller, and I'm going to create 2 inputs for it. And they're going to be on-off button user inputs. These are going to correspond to a left button press and a right button press. I'm going to create one. I'm going to repeat, hit that little button again, hit, then the second one. So we now have 2 new inputs that we've just added. And I'm going to name the first one left to spin the camera left, and the second one right to spin the camera right. And actually, you can set a default binding here. You can set the left one to be the left arrow key, and the right one to be the right key. So I just push the key after clicking that to assign it. So now we have a player controller that will has 2 inputs to it, left and right. And you'll see that when you create those new player inputs, it creates 2 new events. And these are the events that we have to implement to make it spin to do something when we push the button. So I'm going to click on both of these to create little entry points for it. So basically so I'm going to write a little bit of code and I'll explain it as I'm writing it. The first thing we're going to do is we're going to define a variable in this node that is going to be our magnitude. And this magnitude basically is a value that when we hit left, we're going to increment it, or we're going to, on left, we're going to decrement it by 1, and when we go right, we're going to increment it by 1. So if b value, so what I have to do is I'm only interested in if I'm pushing the button down. So the way these player inputs work is this function will get called when I push down and when I let go. When you push down, this b value is equal to true, and when I let go, it's equal to false. So we're only interested in when we're pushing it down. So if b value is essentially testing for that. If it's true, if I'm holding down the button and not letting go, I'm going to set this magnitude value to magnitude value plus 1. And then I'm going to do the inverse here for when we go right. We're going to subtract 1 from the magnitude. And the last thing we need to do is actually create the spinning animation. And we're going to do that by using an onTick event. And so actually, if we click on the parent node here, you'll see under its events, there's this onTick. And that's what we want to actually implement. It's all implemented within the same kind of space. We could also have just typed in node.onTick, but in this case, I just wanted to show you where that is. It lives on the parent node. So the player controllers where those events live, when we push buttons, and then the root node is where this onTick event lives. So now basically what we want to do is on every frame, we want to either animate it in the direction that our magnitude value is currently set at. So the only tricky thing here is if we just simply add the magnitude value to the rotation of the camera, it'll spin at a rate that will correlate to the frame rate. So if your frame rate's really fast, it'll spin much faster, and if it's slower, it'll spin much slower. So we need to normalize it for the frame rate. And so I'm going to write a little bit of code that does this, and I'll explain it afterwards. I'm going to basically calculate a new variable called delta, and it's equal to our current magnitude value times, and I'm going to basically get the self, get space, get timeline. This is our space's timeline. And then there's a function get total time elapsed since last tick. I believe is the function. I have to look this up because I always forget. So I just hit F1 on it, and when I hit F1 on it, it gives me the documentation for it, and this is the function I want. Get time elapsed from last tick. I'm just going to copy and paste that. So I always forget the exact names of these functions. And so this is actually going to be in a time value. I have to convert this to seconds. I'll try to explain this after we see it working. And then so now that we have this nice normalized delta that's nicely normalized, irrelevant of our frame rate, we can now actually perform the animation on the camera, on the node spin. So I'm just going to say self.setWorldRotation is equal to self.getWorldRotation as Euler angles plus vector 3, 0, 1, 0. In this case, the 1 here is going to be our delta. So because we're spinning it along the y-axis. And so this is no different than setting the y value here. When I go in here and I rotate this y value, that's what we're setting. This value here is what we're setting, is the center value here that we're setting according to this delta.
You said self colon.
Self colon, yeah, that's important. This is not dot. It's a colon that you want to use. This is a Lua particular thing. It basically says the self is the node. It has this function called setWorldRotation, which we're going to call. And so we call that function, and we do that by then taking the current rotation, whatever it happens to be, and then we add in this offset, which is basically the offset is calculated from this delta value. Anyway, let's see if this works. Oh, and one last thing that we need to do is we need to assign this node as the current player node of this viewport. And to do that, we're just going to right-click on it and set as viewport player node.
What does that do?
So what this does is it assigns this node as this viewport's player node. And that means that all the inputs, like keyboard inputs, will get dispatched and sent to this node, which in this case has this player controller. So it basically connects hitting a button, piping through the viewport, and then making its way to our player controller, and then calling our events. So now I'm going to hit play, and the left makes it go left. The more I press it, the faster it goes. And then I'm going to hit right, 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 and now it goes in the opposite direction. So let's break down the code a little bit again, just to kind of understand exactly what's going on here. I'm going to open the script that we just wrote, and I'm just going to try to peel this apart a little bit. So again, every time we push one of our keyboard buttons, they, on the one hand, it'll keep incrementing this magnitude value. If I go left, it keeps going magnitude 1, 2, 3, 4, keeps getting bigger, this magnitude value. When I hit the right button, it subtracts it. So it keeps going, it'll approach 0, and then it'll go inverse, and it'll become negative. -1, -2, -3, -4, and so forth. Then on tick, this function gets called every frame, whereas these functions only get called when I push the button. This gets called every frame. I'm going to take that magnitude value, that's either 1, 2, 3, or -1, -2, -3, and I'm just going to multiply that basically by the amount of time that's elapsed since the last frame. Because we need to scale it by that value, or else the higher your frame rate is, the bigger this value is going to get, and we don't want that. Because if your frame rate is only 30 frames a second, we want it to spin at the same rate as if your frame rate is 100 frames a second. So the trick here is to take that magnitude value and just multiply it with the time that's elapsed since last frame. And then we actually have to convert that to seconds, because a time value is this arbitrary, is this container that contains the time, and in any kind of form, we need to specifically say we want it in seconds. So it's basically saying this is essentially converting to rotation per second, angles per second is what this is essentially. So you may have to play with this, and you can multiply this by a scalar like 0.1 if we want to spin it slower and affect that less, or maybe even easier, we can just say, instead of subtract, we can say 0.1 here if we want those increments to be smaller. So then we just take this delta, we basically say our rotation, we're going to set our rotation equal to our current rotation plus this offset. And that's basically how it works. I'm going to set this back to 1 here. And that's it. And then once we hit play, we can hit left, make it go left, and right to make it go right. So that's it. So thanks for watching.